We're now going to go ahead and take a look at the intermediate value theorem. Intermediate value theorem says if your function is continuous in a closed interval, then it goes between two different y values. It has to take on all those y values between those 2 points. And it has to occur between the x coordinates of those two y values. Now, the intermediate value theorem is a existence theorem. It doesn't really tell you how to find it. It just lets you know if it exists or not. And so that's what an intermediate value theorem does. Now, here's another example of a function. Why does this not apply to the intermediate value theorem? Well, it does not apply because it's really not continuous at x equals 1. Because when you come in from the right here, with numbers slightly greater than x, you plug in 1, you get 2. Try your limit from the left, so number slightly less than 1, you have to do this one here, and you get 0. Since your one-sided limits are not equal, it's not continuous. So you cannot use the intermediate value theorem unless it's a continuous function. So here we have a problem. You're asked to use the intermediate value theorem to show that you have a 0 between 0 and 1. Since we have a continuous function, we know we can use the intermediate value theorem, the IVT. Well, first of all, we need to figure out, well, what do we get when we plug in 0 into our function? Well, when we plug in 0 into our function, we get -1. And then we got to see what happens when you plug in 1. Well, plug in 1 and you're going to get 2. Well, we would say, hence, there's going to be a 0 between 0 and 1 by the IVT because at x, you're below the x being 0, you're below the axes, and at x being 1, you're above the axes. And the only way to go from below to the axes to above the axes is to actually cross the x-axis, meaning you have a y being 0 or the 0 of a function. And that would have to occur between 0 and 1. And that's what the intermediate value theorem is saying.